Hello and good day, everyone. This is a continuation of our series on data representation and binary conversion. In this video, we are going to subtract numbers by using the two's complement representation. And this example, we are going to show how addition is done, especially when we have, or rather subtraction is done when we have an expected result which is positive. In our regular site, I have a summary of the method of subtracting binary numbers using the two's complement form. So we have the following steps. If you are to subtract b from a number a, we first have to convert them both into binary. And after which, we are going to make sure that they have the same fractional and integer bits, which means that the bits before the binary point should be the same, and the bits after the binary point should also be the same both for a and b. If they are not the same, on the integer part, we add a shorter number with the leading zeros, and it will not affect the quantity. Now, the shorter fractional part will also be added with trailing zeros, because after the binary point, trailing zeros are insignificant anyway. After that, we are going to take the two's complement of b, where we invert zeros to ones and ones to zeros, and we add 1 to the result. We have to make sure that the 1 is added to the least significant bit or the rightmost bit after the binary point. Now, and then we proceed to performing the two addition, regular addition. Now, in case there's an overflow or a last carry 1, we are supposed to discard that overflow. It should not be part of the quantity. However, we are going to use it as an indicator of the sign of the result. If the last overflow is 1, the result is to be treated as positive. If it's 0, it's to be treated as negative. And then to check our answer, we can convert it to decimal. Now, let me show you an example. For example, we are going to to subtract the number 530.725 from 1215.2136. So let us now start with the first step, which is to convert them both to binary. In this case, we convert A. With 1215, our first pick is 1024, followed by 128, followed by 32, followed by 16, followed by 8, and we have 7, so we have three ones to follow. With 0.2136, our next pick will be 0.125. We can pick 0.06. We can also pick 0.015, and we can pick 007. We can pick 0019, and that's our last pick. Now, in this example, in this case, however, we are not going to pick, rather to mark the squares after the last one. We're only going to mark the squares before the last one, going to the left with zeros. Only the vacant squares. Okay, so now we have a conversion of A. So we set this aside for the moment. Put it somewhere. Because the next thing to do is to convert B. Before we do that, we will erase our previous solution to make way for the new value. Let us just copy B and remove the negative sign. We are removing the negative sign because we are going to convert it to its complement anyway. Okay, let us now start the conversion. Our first pick is 512, followed by 16, followed by 2, and then followed by 0.5 over to the binary point, followed by 0.125, followed by 0.06. We can pick 0.03125, and we can proceed to 003, and 0019 is okay, and that's the last. Like the usual case, we are going to start marking from the last one, going to the left. Okay. Place them with zeros. Now we have marked B. We can now copy this and compare with the bits in A. Now let us compare both the integer part and the fractional part. In the fractional part, they have the same number of bits, so we don't need any adjustment. On the integer part, we know that B is shorter than A, so we add it with a leading zero. So that's the second step. Okay, we make sure that they have the same number of fractional bits. Now we proceed over to the next step, which is to take the 2's complement of B. Take the 2's complement of B. We first take the 1's complement and add 1 to the least significant bit. So in the 1's complement, we are supposed to flip the zeros to 1's and 1's to zeros. Let us do that now. So this 0 becomes a 1, this becomes a 0, followed by 4 1's, followed by a 0, 1 1, followed by a 0, and a 1. Now let's also flip the fractional part. 0, 1, 0, 0, 0. This is 1, 1. This is 0. This is also 0. Okay, this is the 1's complement. Now, we will proceed to taking the 2's complement by adding 1 to the least significant bit. In this case, this is easy because we will not have any other carryover. 1 plus 0 is just a 1. And that does the 2's complement of B. So, after taking the 2's complement of B, we perform normal binary addition, during which we place a copy of A below B. Doesn't matter whether it's below or above. And we start normal addition. So 1 plus 1 is a 0. Let us change the size of the font. 1 plus 1 is a 0, carry 1. 1 plus 0 plus 0 is a 1. 1 plus 1 is a 0, carry 1. 1 plus 1 plus 1 is a 1 with a carry of 1. The next bit becomes a 1. This is also a 1, this is a 1, this is a 1, but this is a 0. We just copy the binary point. And then we add the integer part. So 1 plus 1 is a 0, carry 1. This will be a 0, carry 1. 1 plus 1 plus 1 is a 1 with a carry of 1. Like the succeeding bit, it's also 1 with a carry of 1. So 1, 0, 1 is a 0, carry 1. 1 plus 1 plus 1 is a 1 with a carry of 1. The next bit is a 0 with a carry of 1. Also a 1 with a carry of 1. Also a 0 with a carry of 1. This is a 1. Now the last addition is 1 plus 1, which is a 0 with a carry of 1. Now in 2's complement addition, if we have a last carry or an overflow, we are supposed to throw away or to neglect the last carry. So in this case, we'll just mark it with a different color to remind us that this is not part of the quantity. However, we use this as an indicator of the sign. Being a 1, we expect the result to be positive because the last carry is a 1. If there's no carry, the last result should be treated as a negative. So we can now concatenate our answer using the concatenate formula. We start over to the bit after the overflow and to the last bit. So this is supposed to be our answer. So in the actual exam, you're going to match this to one of the choices. If you find a match, you pick that choice. Otherwise, you pick none of the other choices. Now, how do we check this if this is correct? What we will do is just copy our result to our original table and find out the resulting sum. Okay, do that here by pasting it here. Okay. And our sum is 684.4882. It's not exactly the same because we did not convert also exactly the same. So this is how we subtract using 2's complement form. and in this case, our answer was expected to be positive. In the next video, I'm going to show you examples on which the result is going to be negative. I hope you follow. See you in the next video. Bye for now.